Okay, so anyway, we do the derivative, which I did the natural log derivative. So I put that whatever's under natural log goes on the bottom. The denominator goes on the top. And we're setting it equal to 0 to see where this object is stopped. And I had made a mistake earlier because I plugged this into the wrong part. I'm supposed to plug the number 0 in up here at the top. I'm supposed to plug 0 in to this thing right here because that's our derivative. So that'd be a negative on top and 0 on the bottom is a positive 10. So that's going to be a negative there. And this thing is supposed to stop at 0. 0 is included, so I don't do anything else. So we're supposed to know velocity. When velocity is negative, it's moving left. So the answer to this question is going to be, we're going to write this down. I'm underlining it. The particle P is moving left when T, I don't want to put the T yet, 0 is less than or equal to T is less than 1. Not equal to 1 because that's when the object would be stopped. So that would be the answer to number 1. And it doesn't say why, but if it did say why, it would be because B is less than 0 on that interval, in case that says it on the test. So that's part A. Part B says from 0 to 8, find all the times t during which the two particles travel in the same direction. Okay, so this one is already velocity. And we already know with this first one, because we just did it, particle P is negative here and positive here out to 8. Because this is the velocity right here. So we're going to take and solve this one. So we need to set this equal to 0 because it is already velocity. And we're going to factor this, and this factors to t minus 3 and t minus 5. So at t equals 3, this object stopped, and at t equals 5, this object stopped. So the velocity of Q is going to be 0 at 3, and 0 at 5, and then we're out here at 8. So we got to pick a number. I'm going to pick 1, and I'm sticking it into the original equation right here. So we get 1 minus 8 is negative 7 plus 15. That's a positive. And then from 3 to 5, I'm going to pick 4. I get 16, and 15 is 31, and negative 32 is negative there. I'm going to pick 6 and get 36. 36 and 15 is 51. 51 minus 48 is a positive right there. So we want to know, when is this object moving in the same direction? So if you look here, the object P over here starts moving to the right at 1, and this one is already moving to the right at 1, and it moves to the right to 3. So they're going to be moving in the same direction to the right from 1 to 3. And then 3 to 5, this one's moving up, but this one's still positive. And then this one is, both of them are moving right from 5 to 8. So find all the times which two particles move in the same direction. So this answer would be, we would say the particles move right on these intervals. But it does, again, it does not say why does it move right. So you really don't have to. If you want, you could say because both velocities are greater than 0 on those intervals. You could even say they have the same sign on those intervals. Okay, so that's part B. Part C says find the acceleration of particle Q. So we're only worried about this one. And we want it at time t equals 2. And then we want to know, is the speed increasing, decreasing, or neither at 2? So we did this one a while back to know if we're speeding up or slowing down. The acceleration and velocity both have to have the same sign. But to get acceleration, we have to do the derivative of this. Now, we need to tell the person, again, we know the derivative of b of t is equal to a of t. So when we do the derivative of that, we're going to get that a of t is 2t minus 8. Okay, so I wish I'd have left my last thing up there, but anyway, we want to find when this object is, when the acceleration is 0, and we saw that we get a t equals 4, the object is 0. So what we need to do, I guess we really didn't need to do that because we only want t of 2. So we're going to do aq of 2. We're going to plug 2 in for t. And we get negative 4. So the acceleration is negative 4. Okay, at 2. So we want the velocity at 2. So we're going to use that original problem we did the derivative of, which is 2 squared minus 8 times 2 plus 15. So that's going to be 4 and 15 is 19. 19 minus 16 is 3. So do we see the velocity is positive and the acceleration is negative? So that means we would say the speed is, let's see, decreasing at t equals 2. And that's because velocity is greater than 0 and the acceleration is less than 0 at t equals 2. So that is the third problem. Or you could also say velocity and acceleration have opposite signs. Find the position of particle Q the first time it changes direction. So we actually did this earlier. And this says find position when Q changes direction. So if you recall back to when I was doing part 2, where we did velocity, we found the first time it changed, the Q changed direction was at t equals 3. It was positive to the left and negative to the right of that. So what we want to do is find the position when t equals 3. So we want to do, and they gave us this for Q up here, which is another point. They're telling us that x of 0 is 5. So this is going to be a fundamental theorem of calculus, which is going to be the integral from 0 to 3 of t squared minus 8t plus 15 is going to equal x of 3 minus x of 0. So the integral over here is going to be t cubed over 3 minus 8t squared over 2 plus 15t and x of 3 is what we're looking for. And we know from the given up there at the top that x of 0 is 5. So we got to plug 3 in here. So when I take 3 and cube it, I'm going to change colors and go to the top. And put 3 in there and cube it, I get 27, and 27 divided by 3 is 9. Now you get minus, and 8 over 2 is 4. 3 squared is 9. 4 times 9 is minus 36. And then 15 times 3 is positive 45. And that's going to equal x of 3 minus 5. And then I'm going to add these over here together. 45 minus 36 is 9. 9 and 9 is 18. Then I'm going to add the 5 over, so x of 3 is going to equal 23. So that would be our answer. The first time the object changes direction, it's at position 23.